Problem number one, you're given a figure and you're asked to find the length of an arc CD. So you follow the formula R theta and substituting the values, you'll get the 9.75 centimeters. Next, you have to find the shaded area. So it's the whole triangle minus the area of the sector. Here's the formula for the area of the triangle and the area of the sector. Subtract the two values, you'll get this, and intrinsic fig is equal to 16.4 centimeters. Problem number 3, you have to differentiate the function ln x to the second power. So this is a chain rule. So 2 times ln x times the derivative of ln x, which is 1 over x, will give you this. Show that the value of x, or the tangent of the curve y, is parallel to the tangent of y equals x cubed minus x squared minus 6x will satisfy 2 ln x equals 3x cubed minus 2x squared minus 6x. If they are parallel, they must have the same slope. So we find the equation of the slopes of y, and we have f of x already solved in a, and then we equate the two because they are equal. We simplify, and then we have to prove this part, and it has been shown here. So it has answers already given here. It has been proven. So letter C, find these values of x. So you find these values of x. For this function, you can use either uh, your GDC, the numerical solve, or the graph. If you graph the function, you will have this, and this gives you the value of x, which is equal to 0.340 and 1.86. Problem number 3. A particle moves with velocity as given, where the time is greater than or equal to 0. You have to find an expression for acceleration. So acceleration is the derivative of the velocity. So this one makes use of product rule. So the first term times the derivative of the second plus second term times the derivative of the first will give you this, and just arranging these terms you'll have this. Okay, letter B, find the distance moved in the first 2 seconds of motion. So S, which is the displacement, but this, we're looking for the distance, we'll get the absolute value. So given velocity, to find displacement or distance, you get the integral of the function. So it's a reverse, but here, since we're looking for the distance, uh, it must be absolute value. So you have here, but make sure that your GDC is in radian mode. Okay, the given is in meters, centimeters, so that's in radian. So 4.76 meters.